Today we are going to start class 11 chemistry, chapter number 9, acid base chemistry and pH. Today our topic of discussion is Bronsted Lowery concept. First of all, let's understand how the concept of acids and bases evolved. In 1923, two chemists J. N. Bronsted from Denmark and J. M. Lowery from England independently expand the existing Arrhenius theory of acids and bases. The main limitation of the Arrhenius theory was that it only described acid-base reaction in water-aqueous medium. To overcome this limitation, Bronsted and Lowery introduced a more general idea. According to them, acid-base reaction involved the transfer of a proton hydrogen ion. So under the Bronsted-Lowery concept, an acid is a species that donates a proton, while base is a species that accepts a proton. Let's take an example to understand this concept clearly. When HCl is dissolved in water, it donates an hydrogen ions to water. The water molecule accepts this proton, forming a hydronium ion. We can see this reaction. In this reaction, HCl acts as the acid proton donor, while water acts as the base proton acceptor. Hydronium ion is the conjugate acid because it formed after water accepts a proton, while chlorine is the conjugate base formed after HCl donates a proton. So we see that a conjugate acid is formed when a base accepts a proton, and a conjugate base is formed when an acid donates a proton. This example gives us two conjugate acid-base pairs, HCl, chlorine and water hydronium ion. Now let's consider another reaction, this time involving ammonia. When ammonia dissolves in water, a proton from water is transferred to the lone pair on the nitrogen atom in ammonia, forming ammonium ion and hydroxyl ion. Here we can see from this equation, when ammonia and water react, they form ammonium ion and hydroxyl ion. Here ammonia is the base, water is the acid, needs a proton, hydroxyl is the conjugate base, ammonium ion is the conjugate acid. Again, this reaction shows how proton transfer leads to the formation of conjugate acid-base pairs, ammonium ion, water, and hydroxyl ion. From these examples, we observe that water can behave as an acid as well as a base. This kind of substance is called amphoteric. An amphoteric substance is one that can act either as an acid or a base, depending on the other reactant in the reaction. The Bronsted-Lowery concept is not limited to reactions in water. It can also be applied to solventless reaction. For instance, when gaseous ammonia reacts with gaseous hydrogen chloride, they form solid ammonium chloride. Here we can see this equation. Here HCl and ammonia react and they form solid ammonium chloride. In this case, HCl donates a proton and is the acid. Ammonia accepts the proton and is the base, even though there is no hydroxyl ion involved. Now we see some examples for better understanding. Here we can see in table when nitric acid and water react, they form hydronium ion and nitrate ion. Here nitric acid is the acid because it donates a proton to water, while water is a base because it accepts a proton from nitric acid. Hydronium ion is the conjugate acid because it is formed when base accepts a proton from acid, while nitrate ion is a conjugate base because it is formed when nitric acid donates a hydrogen ion to water. We can see from another example, when sulfuric acid and water react, they form hydronium ion and कहते हैं bisulfate ion. Here, sulfuric acid is acid because it donates a proton to water, while water is a base because it accepts a proton from sulfuric acid. Hydronium ion is the conjugate acid because it is formed when acid accepts a proton from acid. while bisulfate ion is a conjugate base because it is formed when acid donates a proton to base. In third example, we see that when water and carbonate ion react, they form bicarbonate ion and hydroxyl ion. In this example, water is the acid because it donates a hydrogen ion to base, while carbonate ion is a base because it accepts a proton from hydrogen. Bicarbonate ion is a conjugate acid because it is formed when base accepts a proton from acid, while hydroxyl ion is a conjugate base